problem, like I mentioned last time, the first thing we need to do, which is, again, we ask ourselves, is this 3 item here, or does the 3 commissioner that we chosen, do they give us any specific order that we need to choose? Or is there any specific ranking, right? So in this case, they don't have it. We don't have any order. There is no ranking involved. So we know that this is our combination problem. So looking at this thing here, they ask you how many possible choice can we get, right? How many possible choice can we choose 3 commissioner or 3 committee, 3 people committee from the group of this many male and many female, right? So looking at this thing here, we did this yesterday, which is we know that we have to add 7 and 9 to give us 16. And from there, we know that we have to choose 3 people for this committee member, which is, again, 16C3, which is, we know that this is the total possible outcome, or not outcome, but number of ways that we can choose 3 people from a group of 16 people where the order does not matter. So again, this is your, if you later on, as you can see, number 4, they ask you for probability, which is later on, when they ask you for probability, you have to, in the sense, ask yourself, what is the total ways that we can choose something, right? So looking at this thing here, number 2, they ask you how many different choices are possible if all of the 3 committee member are women, right? So now they kind of specifically ask us that we just want the woman, but among the women still there is no ranking or there's no order, right? There's no one first, second, or third. So we're still using a combination, but in this case, we're just looking for the woman, which is, we only have 7, right? 7C3, which is 7 combination 3, which is, we have, using your calculator, we have 35, right? This is the number of ways that we can choose 3 women from the group of 7 women alone, right? We don't care about a man. And again, the next question, they ask you how many different ways can you choose all of the men, which is, now we have 9 men. And again, if you look at this thing here, I did not mention this yesterday, but if you look at this thing here, and if you take the 35 plus the 84, if you take the 35 plus the 84, just, because this is the number way that you can choose just the woman. This is the number way that you can choose just the man, right? If you add them together, you will have 119. Everybody see that the 2 extremes, you have just woman and just man. And if you add those 2, it's only 119 of them, right? The total way that you can choose 3 people from a group of 16 is 560. Meaning if you take 560 minus 119, 371 different ways left, meaning there are 371 different ways that you can choose 2 women, 1 man, and 2 men, one woman, in the sense of those, or not order, but those combination. Okay, so again, these 2 combinations is just the man by himself and the woman by himself. Okay, but this is the total way you can choose 3 people in general. Doesn't matter if it's man or woman. Okay, so now in order for you to do number 4, number 5, and sometime on your Connect Math, I'm not sure if there's a problem in Connect Math that they just straight in go and ask you find the probability and not ask you to find number 1, number 2, or number 3. If there is a problem and they say, what is the probability of select 3 committee member or 3 people and all 3 of them are women, then you have to know that in order for you to find the probability, you need to know the total ways that you, in general, in the total way of choosing the amount from a group of people that you have, which is, in this case, again, to find a probability for this problem is easy because we know the total ways of choosing 3 people from a group of 16. So to find that probability, this is what we have, which is the number way we can choose the woman over the number way we can choose 3 people from a group of 16 people in general, which is this thing here. We have 35 divided by 560, which gives us 0.0625. And lastly, this thing, what we have was, again, how do we find the probability of at least one of them is man, right? At least one of them man, which is, remember, to find at least one, we have to find the probability of one minus the probability of none, right? The probability of at least one person, at least one thing is one, the total probability minus the probability of none. So looking at this thing here, once we have this, which is, again, we know the probability of none of the three are men is the same as the probability of all three of them are women, which is, looking at this thing here, we can take one minus the probability of all women, which give us the probability of at least one man is 0.9375. Okay. Question. Any question here? So one thing is, ladies and gentlemen, one thing is not, again, if you were to say why is not 84 over 560? Well, 84 over 560, that is just the probability of just all men. Okay, if you again, the probability at least one man, consider all men in there too. So again, don't just take this and divide by 350 unless they say what's the probability of 3 officer, right? Or what's the probability of this 3 committee member are all women, then you take the 84 divided by 560. Okay, so again, question with this problem here. So if you don't have question with this thing here, the last problem we have for 4.4 is this problem. And some of you guys probably did this problem on your homework yesterday. I received 2 emails. So again, if you did this problem on the homework yesterday, we did not go over. So today, this is what we will go over, so that at least you guys can see how to attack this problem for those of you who did not do it. How to try to analyze this thing here, or making the sense of what they asking you, right? So they ask you this thing here, which is keep your password safe, right? That's the name of the problem. So looking at this thing here, this is what they ask you is, a computer password consists of 9 characters. And again, your password, your problem can be 10 or 7. I just picked 9. Again, replication allow, meaning you can use A if you want to for your password, 9 of them, right? And now this is what the question asks you is, again, if the computer password consists of 9 characters, replication or allow, meaning you can repeat your number or your letter. So number 1, they ask you how many different passwords are possible if each character may be any lowercase letter or any digit, right? So looking at this thing here, reminder in our license plate, right? In our license plate problem, I ask you, if you have this thing here, you say, oh, there's no combination. They didn't ask me to choose some from the group of something. In the way it is a permutation problem because of the order matter. But again, treat this as a fundamental counting principle. How many characters do we need? Which is, in this case, everybody see that we need 9 different characters, meaning there are 9 different slots that we need to fill in to create this password. I need to have 5 different items in it, right? Which is, now looking at this thing here, at each slot, how many choice can I put in? Which is, again, at the first slot, I have 36 choice. Why 36? Because there are 26 letter and 10 digit, which is 10 number that I can choose from, right? I can choose from A to Z and from 0 to 9, which is, in this case, this is what I have is at the first digit, I can choose those 36 items. And I can choose Z first, right? And the second one, how many options I can have, which is, again, at the second item I can have, which is, again, 36 option 2, in the way that I can repeat my item, right? So looking at this thing here, as you can see, to find this possible password, which is, again, we need 9 different slots to create this password. And at each different slot, which is, again, at the first slot, I have 36 choice. second slot 36, so on and so forth until 9 of them, which is the same as 36 raised to the 9 power. 36 times 36 times 36 raised to the 9 power, which is in this case on your homework. Again, if you type this in your calculator, I probably should show you. I will show you a calculator in a bit. But if you do this in your calculator, they will give you e to the 14, which is again, your Connect Math will tell you how many decimal they want in scientific notation. And again, you have to put in scientific notation because the number is too big, right? So looking at this thing here, everybody see that why we use 36, right? Again, 36 is the total choice that we can choose. And why do we have 9? Because your password need to have 9 character, which is 9 different slots. Okay, if your homework, if they have 11, you have 11, which is again 36 raised to 11. Now, number 2, how many different passwords are possible if each character may be any lowercase? So looking at this thing here, now they just want just letter. They don't care if you put a number in it. Well, not that they don't care. They don't want you to put a number in your password. They just want to know that what is the possibility or what is a possible password that we can create if we only using letter, which is again, what are the total choice that we have now, which is now, if it's letter by itself, we only have 26 letters, which is again, as you can see, is 26 times 26 times 26, all the way to 9 different letter, right? Which is 26 raised to the 9 power, which is again, this is what we have. And now they ask you how many different passwords are possible if each character may be a lowercase or digit, and at least one character must be a digit. So again, let's go back to the at least one criteria, right? Let's go over the at least one criteria. Remember, what is the at least one criteria? Well, the at least one criteria is to find the at least one, we have to take the total probability minus the probability of none, right? That's what the at least one is. And that is where they want to connect this. That sometimes they don't ask you for probability of at least one, but we can use the concept of at least one here, which is how do we know that we need to have at least one digit? Well, to have the at least one digit, do you agree that I can take the total amount, the total possible password that I can create, minus everything that does not have a digit in it, right? So looking at this thing here, part 3 is basically, again, this is all they tell you is, this is the number of ways, number 2, the number of ways that you can create your password, and it does not include any digit at all. And number 1, this is the total way that you can create your password, that you can have digit and number. So this is the total way that you can create a password consist of 9 character, include number and letter, right? And this is the number way that you can create the 9-digit password that only have letter. So to find at least one digit, which is what you need to do, is you need to take the total, which is the total is 36 raised to the 9 power minus 26 raised to the 9 power. And ladies and gentlemen, please, you have to type it this way on your calculator. Please do not using this number here. Do not using 1.016 to the 10 times 10 to the 14 minus this number. The reason is because we guesstimate here, not we guesstimate, because we routing, because we route up the number. So if you take this number and minus this number, you might be off a few because we route it, okay? So when you do this thing here, you need to take the total, which is 36 raised to the 10 power, not 10 power, 9 power, minus 26 to the 9 power, which is, again, if you take this thing here, which is, again, your answer will be 9 point, which is, this is where you round. You only round, like I mentioned, you only round at the end, or your final answer. That's where you round. Don't round in the middle of your process, okay? Meaning, again, this is all we do is we take the total of the number 1 minus the total of number 2. This will give me the at least one digit, right? I take the total minus the item that there's none, right? So question with number two, or number three here. Number two, hopefully you guys see that it's easy. We only consider letter. But number three, because we applying the rule of probability of at least one, right? So at least one is basically, again, take the total minus none. Okay, so this is what we have, which is the total, which is 36 to the 9 power minus 26 to the 9 power. So now they ask you this question here. Well, if a computer generate the password, right? You don't come up with a password. You just go in the computer and say, generate me a password that have 9 characters at random. And it can be any lowercase letter and any digit, right? Now they ask you, what is the probability that the password contain all letter? So again, remember, how do we find probability? Well, to find the probability, we need to know what we're looking for over the total possible way, right? Which is, again, to find a probability, this is what we have. We know that number one, that is the total possible way that we can come up with the password, right? And again, what is the way that we're looking for? We're looking for just the letter by itself, which is looking at this thing here, which is just the letter by itself, which is, again, how many ways can I have just the letter or only letter? Which is, everybody see that we have 26 raised to the 9 power, because that is how many letter I have, which is 26 to 9 power divided by 36 to the 9 power. Why 36? Because that's the total possible way that I can choose. Which is basically, they tell you take the result of number 2 divided by the result of number 1, which is, again, this is what you have, which is, reminder, your probability is always a decimal, right? Which is 0.0535. This is the probability of have just letter, right? Which is very small. As you can see, well, the probability is only roughly 5.4%, right? Out of 100% of all the password is only 5%, roughly 5%, 6%, right? That is considered just letter, right? And again, as you can see, the next thing is they ask you what's the probability that at least one, right? The computer generate this thing here, they generate this, and what's the probability that they generate this password and this password have at least one number in it, right? Which is, again, to go back to our probability of at least one, we know that we can take 1 minus the probability of none, which is, again, we know that this is the probability of all letter, meaning that is meaning, again, what does it mean? All letter, same as the previous problem. All letter meaning none of the item have a digit in it. None of the item have a number in it, right? Which is, again, we can do this, which is we can take 1 minus this item, which give me this answer. Or if you want to, you can take this item here. You can take 36 minus 26 divided by this item. You know, you can type this as in your password, or the thing is please don't take the result at this thing here. Don't take the result and divide to this result. You have to use as a whole number this way. Okay. So looking at this thing here, question with end of this part. Question with number 1, 2, 3, 4, 5 here.
I have a quick question, Mr. Tran.
Go ahead.
Would it change anything if it said you had to include like uppercase letters too?
Yes, it will.
Okay.
It will double the 26, right? If they say uppercase letter or lowercase letter, meaning now you have 2 more options, right? You can have a capital A or a lowercase a, right? Meaning, again, the letter no longer is only 26 option or 26 choice, but now you have 52 choices, okay, right? Meaning you can use either a lowercase b or a uppercase b, meaning now your letter is double the sign. I don't think they kill you in terms of giving you that problem. But again, they can change it. Instead of letter, they can say, emoji or something like that, right? They can say there are 10 emoji, right? And then instead of the letter, you just put in the 10 or 12 emoji if they give you. But again, the idea here is basically see how can we use in the the fundamental counting principle to apply. You know, this thing here is somewhat, you can apply the combination or permutation in, it's just that at each slot, you have one, you know, you have 36 choosing one, which is 36 choosing one is the same as 36. So instead of using combination or permutation at each particular slot, we just say, okay, the total of the item we have is 36, or the total item is 25. Yes.
I'm still like a little confused on question 1 because it doesn't say anything about 36. So I just don't understand how you got the total of 36, because it just says how many different passwords are possible if each character may be in any lowercase letter or digit. So how did it just says
how many letter in our alphabet?
26.
Right?
okay.
In the letter, meaning again from A to Z, which is if you remember the license plates yesterday, the license plates, your letter, you have A to Z, which is you have 26 letter, right? And the digit from 0 to 9, you have from 0 to 9, meaning there are 10 single digits, which is again the letter and the digit you add together. That's where you get the 36. Okay. So, you know, for instance, this question, they can say instead of like I say, instead of any lowercase letter, they can say there are 15 emoji that you can use for your password, and or there are any digit, right? Then again, instead of the 26, now we have 15, right? So we have say 15 plus 10, which is instead of 36, we have 25. So you have to ask yourself, well, you know, what is the description they're giving us, right? What's the description that they give us, which is in this case, they give us the letter, any lowercase, which is they specifically don't want to have a, you know, a uppercase, and then any digit, which is again, that's why we have 36.
Like, I'm sorry, but like, how did you know that we were using the alphabet to count those? Because like
they say letter, I mean, letter assumed to be the English alphabet letter, unless they say Greek letter, you know, unless they say the Greek alphabet. If they specifically say, you know, any other letter, but in our, if they just say letter, then it's assumed to be our alphabet from A to Z.
okay.
Okay. You know, unless they tell you all the, you know, they tell you that in the Greek alphabet there are 12 letters, like alpha, beta, gamma. You know, unless they state it, then the letter that we're using is our English alphabet letter. Okay. So any question here? If you have a calculator, make sure to see if you can, you know, when you type it in this way. When you find your answer, don't use in the result and type the result in. Okay. So any question with this password problem?